We're starting section 5.1. We want to solve a system of linear equations. We'll start out with a 2 by 2 system, which just means two equations in two unknowns or two variables. We're going to solve the 2 by 2 system by the substitution method and also by the elimination method. And then we're going to see two special cases. We're going to see an inconsistent system and a system of dependent equations. After that, we'll go on to larger systems of equations. We'll solve a 3 by 3 system, which is three equations in three variables, and a 2 by 3 system, which is two equations in three variables. So first, we want to work on the 2 by 2 system. We want to solve by the substitution method. And we're looking at example 1. We have the equation 3x plus 2y equals 11. And another equation, negative x plus y equals 3. We know that these are linear equations. We know that these are linear equations because each variable is raised to the first power. So what does the substitution method tell us to do? In the substitution method, we're going to solve one of the equations for one of the variables, and then we're going to substitute that result into the other equation. Which equation should we start with? Well, really it doesn't matter, but if you started with the first equation and solved for either x or y, you would wind up with fractions in your answer. And that would make things a little more complicated. So let's use the second equation instead. Since the coefficient on x is negative 1 and the coefficient on y is 1, solving for either variable would be relatively easy and would give us a result that doesn't have fractions in it. So let's start out with the second equation, negative x plus y equals 3. And let's just solve for y. In one step, we add x to both sides, and we have the result, y equals 3 plus x. And of course, we could write this as y equals x plus 3. That wouldn't make any difference. And then we're going to take that result, and we're going to substitute it into the other equation, into the first equation. So the first equation says 3x plus 2y. We're not going to write y this time. We're going to write 3 plus x instead of y. All that's equal to 11. And notice now we have an equation that only has one variable in it, the variable x. And so we can solve for x and we can have part of our answer, part of our final answer. So let's go ahead and solve for x. We're going to use the distributive property to get 6 plus 2x equals 11. And then if we subtract 6 on both sides, we'll get 5 on the right. And then on the left side, we have 3x plus 2x. So we can just go ahead and write that as 5x. And then if we divide by 5, we get x is equal to 1. Now we're not done. Our solution is an x and a y value that together make the equations true. So to finish, we need to take that value for x equals 1, and we need to substitute it into one of the equations we already have. We could use the first equation or the second equation. My favorite in the substitution method is this one right here, y equals 3 plus x, because we've already solved for y. So when we plug in 1 for x, we don't have very much work to do to get y equals 4. So together, x equals 1 and y equals 4 is the solution. A lot of times we want to write our answer as an ordered pair. And so we would write 1, 4 as an ordered pair. Or we could even use set notation. And so set notation, remember, has braces. And what this says is just that there's only one solution. So there's only one ordered pair inside the braces. And that ordered pair is 1, 4. The set notation is what you'll see in MyMathLab when you're doing the homework problems. Okay. One more thing I want to say here is that we could check our answer. To check the answer, we're going to substitute x equals 1 and y equals 4 into both equations. So in the first equation, 3 times x, 3 times 1, plus 2 times 4 is equal to 11. We're asking, is that true? Yes, it is. 3 plus 8 is 11. 11 equals 11. And then we need to check the other equation. Negative x would be negative 1 plus y, which is 4, is equal to 3. That's another question. Is it true? Yes, it is. Negative 1 plus 4 is 3. And so that worked. So 1, 4 is the ordered pair that makes both equations true, not just one of them. Okay, so that's the substitution method. That's a quick review. Let's go on and let's learn about the elimination method. Let's do the same problem again. So of course we'll get the same answer, 1, 4. This time we'll solve by the elimination method. And so the goal in the elimination method is to add the two equations together. And when we add the two equations together, we want to eliminate one of the variables. We want one of the variables to cancel out. So the key then is to have opposite coefficients on one of the variables. If we have 3x in the first equation, then we need to have negative 3x in the second equation. Well, how could we get negative 3x in the second equation? We could multiply the entire second equation by 3. If we do that, when we multiply by 3 in the second equation, that's multiplying both sides of the equation by 3, we get negative 3x plus 3y equals 9. And then the first equation is 3x plus 2y equals 11. So we'll just bring it down. And now, if we add the two equations together, negative 3x plus 3x cancels just like we wanted. And we're left with 5y is equal to 20. Notice we have an equation now that only has one variable in it. So that's similar to the substitution method. We start out with equations with two variables, and we work our way toward an equation that only has one variable in it. Now we can go ahead and finish solving for y. We can divide by 5 on both sides, and we see y is equal to 4, and we can put a box around that. And then we just need to plug back into one of the original equations to get the corresponding x value. So maybe the second equation is a little easier to solve, although I don't think it makes much difference. Let's use the first equation. So if we have 3 times x plus 2 times y, we'll replace the y with 4 that we just found. And then 3x plus 8 equals 11. When we subtract 8 on both sides and then divide by 3, we get x equals 1. And so again, we would like to come back and write our answer 1, 4. I'd like to back up to the beginning for just a moment and make sure you see we could have eliminated y instead of eliminating x. How would we do that? We would have multiplied the second equation by -2. We would not have multiplied by 3. We would have multiplied the second equation by -2 and then added the two equations together. You should try that. You should verify that you still get to the same final answer, 1, 4. Okay, let's have one more example of the elimination method, just a little bit trickier than the last example. This time 3x minus 4y equals 1 and 2x plus 3y equals 12. If we want the coefficients on x to be opposites, then we're going to have to multiply both equations in order to make that work. So we could take the first equation and multiply by 2. That's the coefficient from the other equation. Right? That 3 times 2 would give us 6. And then if we multiply the second equation carefully, we can get a -6 on the coefficient for x there. How would we do it? Multiply the second equation by -3. Okay, so let's try that and see how it works. Multiply everything in the first equation by 2, and we'll have 6x minus 8y equals 2. And in the second equation, we'll have -6x minus 9y equals -36. And so when we add those two equations together, the x's cancel. We're left with -17y equals -34. And when we divide by -17, y is equal to 2. Notice we had some other choices when we were setting up the elimination. We could have multiplied the first equation by -2 and the second equation by +3, and that would have been just as good. We also could have eliminated y instead of x. If we wanted to eliminate y, can you see how to do it? To eliminate y, you could multiply the first equation by 3 and multiply the second equation by 4. You should try that and see if you'll get the same answer that we're getting here. We're not quite finished with the problem yet. We still need to find the x value for our solution. So we're going to substitute into one of the original equations. I'll choose the first equation. 3x minus 4 times 2 is equal to 1. And then I'll just solve for x. So 3x minus 8 equals 1. Add 8 to both sides and get 3x equals 9. And then when we divide by 3 on both sides, we get x equals 3. So this time our ordered pair is 3, 2. And if we'd like to use the set notation, we could even put braces around that.